Good afternoon, everyone. We are the Sims team. My name is Jillian Jankowski, and my teammates are Haley Jankowski and John Cuttrell. And today we're going to discuss the biological survey that we completed this summer in the Sedge Island Marine Conservation Zone. So I would like to begin by discussing a little bit of the project history. This is the 11th year that this study has occurred. It began with Dr. Javoff, whose study focused on blue crabs in the zone. His study concluded that juvenile blue crabs were commonly found in the Sedge Island Marine Conservation Zone. And over the years, the study developed into a larger biological survey looking at fish, crab, shrimp. And the results of these studies found similar results that the Sedge Island Marine Conservation Zone was a successful nursery ground where species can grow and thrive. Currently, the Sedge Island Marine Conservation Zone is located in Ocean County, New Jersey, off of Island Beach State Park. This project is partially funded by New Jersey Fish and Wildlife and is in partnership with Save Barnegat Bay. And the goals of this project are to maintain a long-term biodiversity data set, as well as this year was to complete a temporal study of the zone. So here's a quick look at our timeline this summer with this project. In total, we completed 10 days of sampling in the Sedge Island Marine Conservation Zone. As you can see here, the first day of our sampling was June 28th. And then the first 5 days of our sampling following were the 28th through the 30th, July 1st and 2nd. And then the last 5 days of our studies were completed during July 5th through the 7th, as well as July 12th through the 13th. And we had our final presentation in person August 17th. To clarify, we sampled for a total of 10 days during each for a total of 10 days. During each of the first 5 days, we sampled at 6 sites. And then during the last 5 days, we revisited those sites. So in total, we sampled at 30 sites and revisited 30 sites. So another important part of our project was where we sampled. So our project focused on 3 habitat types, including submerged aquatic vegetation, also known as SAV. This is like your eelgrass, macroalgae, and bare surface bottoms, which would be sand. And as I mentioned before, we sampled at 6 different sites each day of the first 5 days of sampling. So of those sites, 2 are SAV or submerged aquatic vegetation, 2 are macroalgae, and 2 were bare. And as you saw above, those were our sample sites. So as we arrived at each sample site, a set of information would be taken in and measurements would be taken. Some of them included time, the GPS location, which was important to take because when we wanted to come back in the last 5 days of sampling, we need to know the exact location so we could drop the cylinder in the same place. Weather condition, wind, depth, tidal flow, current, dissolved oxygen, salinity, and water temperature were all taken. Following that data collection, we would also begin measure different type of data collection, including the cylinder. So right here, you can see is a large cylinder. So we would take this cylinder and we would drop it into our habitat. And then using a tool called the D-net, we would then use this net to scoop the bottom of the cylinder and to collect the species in the cylinder. After that, the scoops would then be placed into bins that we could sort. As you can see in the picture, there's somebody sorting through the bin with a chopstick. And each scoop was searched for fish, crab, and shrimp species. So as species were collected, each individual size was measured, recorded, and then released back into the habitat. And this process was repeated with each scoop until there were 5 consecutive scoops without any collected species. And then this just allowed us to make sure that we had an accurate representation of what species were in that habitat. And then here again is the all the sample sites that we went to. The red represent the macroalgae habitats, the yellow circles that represent the bare habitats, and the green triangles represent all the submerged aquatic vegetation habitats.
So once we were done with in-person sampling, we transferred our data from the data sheets that we used out in the field into Google Excel sheets. Using this data, we conducted 2 different tests, Simpsons Diversity Index, as well as a Shannon-Weiner Index for evenness. For the Simpsons Diversity Index, we use an equation to calculate the diversity for each habitat during the first week and the second week. The equation gives us a value between 0 and 1. 0 meaning that it does not have a lot of biodiversity, while values closer to 1 indicate a higher biodiversity. These pie charts were created to give a visual representation of these biodiversity values. As you can see, higher biodiversity was seen in SAB habitats and lower biodiversity was seen in bear habitats. As you can see, the bear habitats only contain a few species, while SABs contain a lot more species all around. Macroalgae also had higher biodiversity values. For evenness, it is also calculated for values of 0 and 1, with 0 being low evenness and 1 being high evenness. For those unclear, evenness is a measurement of the relative abundance of species within a community. As you see, once again, bare bottom habitats have low evenness because they're dominated by about 2 species, such as sand shrimp and silver sides, while SAB habitats have a higher evenness value because they have more equal distribution of species. Macroalgae also had higher evenness values as well. When looking at the total biodiversity between the first week and the second week was shown to have higher biodiversity, indicating that there was more species present in the second week in more even amounts. We also created a Venn diagram to represent the total amount of species that we were looking at throughout the entire study. As shown, most of the habitats contain the same types of species. However, there were species exclusive to certain habitats.
So the graphs you can see here are separated by type of species, types of things that we caught while we were using the cylinder. So it's separated by crabs, fish, shrimp, and then total organisms. You can see separated by the different substrates, the amounts that were caught on average each day in those substrates, whether in the bottom left corner, you can see all the organisms were added together as an average, while the other 3 graphs are separated by different types. So we also had other graphs to separate it by species. So when you look at the separation by species, it's you can see that there is a difference, a huge difference in looking at the separation by what we were catching and where we were catching them. So just a big one that you can look at the huge differences. If you look at the Atlantic silver sides in the top left corner, you can see the majority of where we caught them was in the SAV, medium was about in the bear area, and then we caught none to little in the macro areas on average per, we just found way more in those situations. So another way that we ran tests was through a t-test. So t-tests are run to basically look at a comparison of data. So what we did was we looked at comparison of 2020 data to 2021 data and basically compared it to see if there was a difference between how similar the conservation zone was between those 2 years. And so t-tests work with a value of 0.05. So when I installed that data and you look at the differences between how many silver sides we caught in 2020 versus how many silver sides we caught in 2021, just as an example, there's not that much of a difference, which is what we were looking for in the majority of the species, and that's what we found. So what we were basically looking for in that t-test was just to prove that there's nothing that's seriously changing within the conservation zone, and it's just showing that this nursery is doing really successful to help bring that area to life, and it's just working really well, and it's just helping to prove that nothing is changing And a big part of what we had in testing is between the 2 weeks, between week 1 and week 2 of testing, we had a storm over the weekend. And so that dropped temperatures down at the beginning of the week by about 3 or 4 degrees Celsius. So that was just through the storm, the rainwater brought that temperature down by a few degrees. And there was even more, as Haley was talking about before, there was a higher biodiversity level and there was more evenness through the species through the second week, which just shows that these species are able to handle these changes on a regular basis, week by week and month by month. And the fact that they can handle these situations and be able to just continue on and actually improve afterwards, which is what we found between those 2 weeks, is just really good to hear and just helping our data to show how significantly important that is.
And in the end, we'd just like to say thank you to Save Barnegat Bay for granting us this opportunity through the student grant. Also, we would like to thank the Marine Academy of Technology and Environmental Science for supplying us with all the necessary equipment that we needed in order to complete this study. Lastly, a big thanks to the New Jersey Division of Fish and Wildlife for also funding this study.
Nice job, everyone. Thank you so much for participating in our student grant program. I have 2 questions for you. I'll start off with the one relevant to your project. So obviously this project has been going on for a long time. So a lot of this is predictable and that, you kind of already have your question formulated and basically what your results are going to be, barring any crazy changes. So I have a weird question, and it's, what was your favorite thing to find every time you pulled up the net out of the silo?
I mean, I really liked seeing oyster toadfish. We only saw about 3 of them throughout the whole study, but they're a really unique species. So it was kind of cool to see something different from the hundreds of sand shrimp and silversides that we saw day to day.
That is a pretty good one. Jillian?
My favorite was the scallops because it was cool to see fully formed scallop. Usually when you find shells, it's half. So those were pretty cool.
You found live scallops. That's very cool.
Mm-hmm.
I wish I was out there to see them. John, what was your favorite?
I have to agree on Haley with this one. It's definitely the oyster toadfish for me. It was just real, it's not something you see all the time. And just like we were talking about, just with seeing the silver sides and the shrimp all the time and just picking through hundreds of shrimp all day long. And then finally with one scoop on that a couple weeks, you get that oyster toadfish or you get that big blue crab or whatever. But the oyster toadfish was definitely probably the coolest thing that we found.
That's awesome. Well, I hope you took lots of pictures out there and you had a lot of fun. So did you have any feedback for folks who might be interested in the student grant program? This is a team project that you participated in, a project that continues each and every year. So students have the opportunity to apply specifically to this project team each year. So do you have anything you'd like to share with folks that might like to apply next year?
It is a extremely unique experience, and it is also a awesome experience. And it's a great opportunity to do something different that most people our age probably don't have the opportunity to take part in, especially living close to the water. We're lucky to have an opportunity like this. So I think it's something that if you're interested in, definitely try out for it because it is something that you probably won't be able to do usually.
Yeah, even if you feel like you don't have the right experience to do a project like this, you get really into the groove, and it's a really fun and great way to learn about the local community, especially the bay, which is such an important part of the ecosystem around here.
Yeah, especially the fields that we're all going into, it's really just important to be able to get those hands-on experiences and be able to go out and do those things, whether it's testing and seeing biodiversity or just studying in a lab or whatever it is, getting your name out there in those fields and being able to do those things and say hey, I got to do this on Barnegat Bay or whatever it is, on whatever project you got to work on. It's just huge to be able to get your hands on doing something and being able to get that experience, especially in this field.
Well, folks, I'm so excited that you got such a good experience out of the Sedge Island Marine Conservation Zone biodiversity team this year. It sounds like you had a lot of fun, and it also sounds like the information you shared means that things are staying consistent, which, if nothing else, it means they're not declining, which is a good thing to hear. So for anyone watching this YouTube video afterward, thank you so much for staying tuned this whole time to hear our students' feedback on their program and their information that they have about the Sedge Island Marine Conservation Zone. If you're interested in applying for the student grant program through Save Barnegat Bay, it is open to undergraduate students who are interested in pursuing research. Maybe you're not sure that you want to do research, or maybe you have a little bit of experience, but you'd like a little bit more. So this is a summer program where we pay college-age students to do science on Barnegat Bay, and these folks did one specific project. You can check out more about this program at savebarnegatbay.org. Click on the word educate, scroll down, and find student grant, and there you will find our bios from these students, their formal paper that they are submitting for scientific review, as well as the past presentations, other presentations from this summer, and an application if you're interested in applying yourself. If you have any questions about the information these students shared today, you can always reach out to education@savebarnegatbay.org, and I will connect you with the appropriate party and person to get in touch with. So thanks so much for watching. We'll see you next time.